Hello team, welcome to this video where we take a quick look at the principles of linear equations, or the fundamentals of linear equations, or the key components. This should hopefully be a review of the first lesson or two that we did at the very start of the year, but we thought, being it's been 2 weeks and been focusing on algebra skills, we should do a quick overview. So this isn't going to include everything in depth, it's just going to be, like I said, a brief overview. So let's get going. We're of course looking at linear equations. We're finally moving into our graphing component of it, but we need to know the fundamentals before we start graphing. So a linear equation is written, a linear equation is any equation that gives us a straight line. And we generally write it in the form of y equals, we have an m in front of our x that we talk about, and then a plus c at the end, where m is our gradient and c is our y-intercept. I should also point out that this might be really handy for your reference book, because this is just the fundamentals, it's an overview. So it's good to take down. So we generally like to write in the form of y equals mx plus c, where m and c are going to be two numbers. It could be whole numbers, they could be fractions, they could be positive or negatives, but they're going to be two numbers. Let's jump quickly at Desmos and have a look and see what happens as we change them. So I've got y equals mx plus c as my equation. Actually, I need to drag this over. There we go. Okay, y equals mx plus c, and then I've got these sliders that I can change my m value and change my c value. So currently m is 2 and c is -4. We can have a look at the graph. So let's have a look at what happens as we change m. So as I make m lower, our line becomes flatter and flatter, or the gradient isn't as steep. And as I make m greater, my line gets steeper and steeper and steeper. Okay, so m affects our gradient. If it's positive, it's going up to the right. If it's 0, it is straight flat across, and if it's negative, it's going down as we go to the right. With our c value, that affects our y-intercept. So let's go back to sort of a regular gradient that we're used to seeing, positive gradient. Our c value is our y-intercept. It effectively just moves the graph up and down, and whatever that c value is the y-intercept, or where the line crosses the y-axis. So right there at 0, 3. And as I move that greater, we can see it goes up. So if I set it to 5, the line crosses at 5. If I move it up to 7, the line crosses at 7. All right. So that's a basic form of a linear equation. Now, gradient, as we talked about, is a measure of steepness. So and we find it from the general form, the general equation, m is equal to our rise over our run. And as I said before, if I just do little axes to demonstrate, okay, if my line is going up as it goes to the right, that is considered a positive gradient. If my line is going down to the right, that is considered a negative gradient. And then if my line is going straight across, that is considered a 0 gradient. We also have got another special case where if the gradient is going straight up and down, okay, vertical line, and technically the gradient is undefined. So that's our different forms of gradient. Now, how do we calculate our gradient? Well, we use that equation that I just wrote before, which is m equals rise over run. And we need to pick two coordinates. Okay. Use two coordinates. And we just want to look at, we can pick any 2 points on the line. When lines are drawn on a grid like this, we can pick any 2 points anywhere, but generally questions in tests and textbooks and all that sort of thing, they won't give it to you on a grid, and they'll just actually label the coordinates. So this one here, if I actually labeled them, it would be 0, -2 for that dot there, and up here that is 3, 4. But to start with this grid, nice and easy, we can just read off our rise and our run. So we want to look at, in our case here, m is equal to, now our run going across, we can quite easily see if we go from going across this way, we can see that we're going across 1, 2, 3. Going across 3, and then if I look for my rise, I can see going up. I can count how far I go up. I go up 1, 2, 3, 4, 5, 6 blocks. I go up 6 blocks. So my gradient in this case is equal to 6 on 3, 6 divided by 3, which if we simplify just gives us a gradient of 2. A fancier way of writing this rise over run, we could write it as y2 take away y1 on x2 take away x1, which just talks about the coordinates of the 2 points. So if I draw another quick graph over here at the left, put a line in there, that, and I tell you 2 points, so this might be -4, -1, and this point over here is 2, say 3, 5. This x1, x2 refers to coordinate dot 1 and coordinate dot 2, okay, where coord 1 is equal to x1, y1, and coord 2 is equal to x2, y2. So in this case, this is our first coordinate. We always try and pick our left coordinate as our first coordinate. So this is first coord. So we could call that x1, and we can call that y1, and we could substitute into our formula. And this is our second coord, okay, or coordinate, and that is x2, y2. And so we could substitute that in the formula. So using that, let's do a quick substitution. I'll just keep using that color. Okay, line. So x2. So first I have a 3. Take away x1. So our x coordinate of our first coordinate is -4. And then I look at my y values. That is a 5. Take away -1. That gives us 5. Take away -1 gives me 6. 3 take away -4 is 7. So I end up with a gradient of 6 on 7. I can't simplify that fraction anymore, so I just leave my gradient as a fraction. To really sum up quickly that gradient, because I just talked a whole lot, this way is the easier way. Just read off how far across do I go is my run, how far up do I go is my rise, read them off. Sometimes, especially with large numbers, using this equation here is the more advanced way. If you're comfortable using that, then do use the equation. I completely recommend it. Rightio. Intercepts. So intercepts are where our line crosses the axes. So let me label these axes quickly. We have our x-axis going this way, and we have our y-axis going up. So we have, for every straight line, we have two y-intercepts. Those y-intercepts will be, not two y-intercepts. We have two intercepts, one called the x-intercept and one called the y-intercept. So we have the x-intercept, where it crosses x-axis. So we can see right there, that's that one, and that occurs at 2, 0. So we could say that that one is 2, 0. And then we have our y-intercept, which of course is where it crosses the y-axis. Which we have down there, which we can see is at 0, 4. Okay. There's two really key bits of information, or two tidbits that will help us for this next section, where we're actually going to try and calculate them from the equations. Our x-intercept always occurs when y equals 0, because if y equals 0, we'll always be on this line. It will always be on our x-axis. So, the x-intercept always occurs when y equals 0, so when the opposite letter is equal to 0. And then same thing for the y-intercept, that always occurs where x equals 0. Because if x equals 0, I haven't moved left or right. I'm always here. I'm always on this line. So for the two intercepts, they always occur when the opposite letter is 0, or our opposite variable is 0. So our very last thing from this introduction is we need to be able to also calculate intercepts, not just by looking at a graph, but calculating them from an equation. So here's two examples, and this is my suggested layout working down. So I naturally just always find the x-intercept first. Let's do that. So we're going to find our x-intercept, this first example, and to do that I let the opposite letter equal to 0. So I'm going to let y equal to 0 because I'm trying to find the x-intercept, and I'm going to substitute this into the equation. So I get 2x minus, now instead of y, I'm going to put 0 is equal to 5, and this is where we need to use our algebra skills and number skills to solve this. Now we get to 2x equals 5. To move that 2, we divide both sides by 2. That cancels off, and we're left with x equals 5 on 2. That's completely fine to leave it as a fraction. If we can't simplify, leave it as a fraction. Now I need to find, that's just one intercept, I need to find the other one, so I want to find my y-intercept. So I let the opposite letter equal to 0, and I go back to my original equation and substitute it in. So I now get 2 times by 0, x minus y stays as y equals 5. So I get 0 minus y is equal to 5, so I get negative y is equal to 5. Now to move this negative, we just move it to the other side, so we get y is equal to negative 5. And that's our two intercepts. Last problem, what have we gone? 14 minutes, sorry, a bit too long, but we'll do our second example. Same process again. I want to find the x-intercept, so I let the opposite letter equal to 0. So I'm going to make y equal to 0, so I get 0 equals negative 2x plus 4. I want to move the plus 4, so how do I move the plus 4? I take away 4 from both sides. That results in that cancelling. So I get negative 4 is equal to negative 2x. How do I move the negative 2x? Well, that's times by the x, so I do the opposite of times, which is divide. So divide both sides by negative 2. That cancels. And I'm left with -4 divided by -2 gives me a positive, and that gives me 2, so 2 equals x. Let me... button. Let me move that up so I have some space. I get 2 is equal to x. Now I need to do the y-intercept. So I let the opposite letter equal to 0. So we get y is equal to -2 times by 0 plus 4. So I get y is equal to 0 plus 4 because -2 times 0 is 0. And I get y is equal to 4. Or you could have recognized this is written, way back at the start, this is written in y equals mx plus c form. C is our y-intercept, so our y-int equals 4. You could have read it straight off. But it's good to know that you can always find it by subletting the other letter equals 0. Right, 16 minutes, a little bit longer than I hoped for, I apologise. But that's an overview of the fundamentals of linear equations. If you have any questions, don't feel free to put it on your teachers on Google Classroom. Thanks, and see you.